Hello, dear student. How are you? I hope you all will be fine. I'm also fine. Thank you. Welcome to our channel. That is AZ Science Group. Let's start today's topic. Today is Hofmann bromide reaction. In short, that is called Hofmann reaction. So, are also called Hofmann rearrangement. So, in this mechanism, in Hofmann reaction or in Hofmann rearrangement, what is Hofmann reaction or what is used for the Hofmann reaction for? The Hofmann reaction, it is actually the reaction of in which that is amide structure, that is amide, AMID, that is amide, that is primary amide because one alkyl group is attached. So when primary amide converts into primary amine, when primary amide converts into primary amine, that is amine when alkyl group is attached with the nitrogen groups and other all atoms are hydrogen. So that will be called primary amine. When the R2NH group, that will be called secondary amine. When R3N, that will be called tertiary amine. But here same also, that is amide. So when the primary amides change convert into primary amine, it will be called, this mechanism will be called Hofmann rearrangement or Hofmann bromide reaction. And this reaction, the mechanism has been suggested on the basis of intermediate isolated during the course of reaction as far. This mechanism actually used for the to isolation of intermediates in any organic chemical reaction. That reaction has very broad use, has very large use in organic reaction synthesis. Okay, let's start the mechanism. First of all, that is one amide group, that is amide, that is AMIDE. The spelling of amide is that there is a lot of difference between amide, amine, ammonia, and you should be need to know about all these things. But I will be discuss only this RC double bond ONH2, that is amide, and in the presence of NaOBr, in the presence of NaOBr, that will be produced from the when the Br2, when the bromine molecule add with the sodium hydroxide or with caustic soda, it will produce NaOBr. So this structure will be produced. When this structure is produced in AOBr, when this compound formula is treated with this in the presence of this formula, this will be called this here is the bromine. This bromine will be attack on nitrogen. When this attack on nitrogen, what will be, it will be directly attached with the nitrogen, like here, that is NaBr. Br is directly attached with this, but here is also oxygen present, here is also oxygen present. So this oxygen will be attack on, this oxygen will be attack on one proton, on one hydrogen, and it will be abstract this hydrogen as a proton. So here is only one proton because here is two proton, and after that the reaction here is only one proton because one proton was abstracted and produce OH. So that is N bromide structure will be produced, N bromide, N BromAmide, N BromAmide, this compound will be produced. Also OH will be produced, one OH and one NaBr sodium bromide will be produced. But once again this hydroxyl group, that will another proton will be abstracted, this proton will be also abstracted by this OH and produce a negative charge on this nitrogen and will be produce N BromAmide anion, that anion will be produced. Once again this bromide, that is electronegative element, so that's why this this bromide will be as a bromide, as a negative charge, as a anion, it will be lose this element, lose this compound. So it will be lose as a bromide ion, is a bromide anion, and here it will be produced nitrogen ions because nitrogen will have two lone pairs, so that's why it will have produce nitrogens. And this alkyl groups, once again this alkyl shift will be occur. This is called alkyl shift. When the alkyl group shift from one atom to another atom in the same compound is called alkyl shift. So compound is same, this alkyl will shift from this carbon to this nitrogen, it will be called alkyl shift. Alkyl shift will occur from this carbon to nitrogen and produced Rn, the N will be directly attached with the R will be directly attached with N, like here, that is Rn. And so there when the electron transfer occurs from this bonds, so that's why carbon will get positive charge, and when the electron transfer occurs to nitrogen and nitrogen, so that's why nitrogen will be get negative charge. Therefore nitrogen has negative charge and C has positive charge. But once again here is negative charge on nitrogen and positive charge on carbon, so that's why they will produce one double bond. This negative charge will shift here and produce double bonds, and as a whole system will be neutral, and that will produce a resonating structure resonance. and it will be stabilized by resonance. And this is also called isocyanate. That is the intermediate of the Hofmann rearrangement or Hofmann BromAmide reaction. That is called isocyanate. Be remember that it is very important term, isocyanate. That is the intermediate of this compound. So once again, they in the presence of water in the presence of water to produce primary amine, to in the presence of water it will further attack, this is oxygen OH will be attack on this carbon and this positive charge. When they are attack on this proton, this negative charge will be shift here. This negative charge will be shift on nitrogen, or you can say that this negative charge will be attack on the proton, that is a 2O1 H and 1 OH. OH will be attack on carbon and H will be at this electrophile will be attack on nitrogen and this center. So that's why it will be produced RNH and here will be produced COH. Here will be produced COH. Once again, this is COH. That is this proton, the bond that is present with OH, this OH bond will be broke and the proton will be shift towards nitrogen and produce RNH2, while that will be produce one double bond between carbon and oxygen. It will be produce one double bond between carbon and oxygen, and will be produce CO2 and also will be produce RNH2 like that is present. OH that I before discussed, that is RNHC double bond O and OH. So here this lone pair will be shift here and produce double bond. So that's why this double bond, this bond between nitrogen and carbon will be shift. So when we will be breaks, and this proton will be shift towards from here to this nitrogen. It will produce RNA2 like this and produce a double C double bond O double bond O. It will be produce CO2 structure carbon dioxide. And in the presence of sodium hydroxide, when they are attacked with the, when they are treated with CO2, that is the product of this mechanism. In the presence of CO2 and in the presence of NaOH, the CO2 will be produced, Na2 sodium carbonate will be produced, plus water will also be produced. And this from primary amide we synthesized primary amine. I hope this mechanism will be clear. Still, if you have any confusion, if you have any question, you can ask me in comment section, as well as you can ask me in my personal WhatsApp or Gmail that I put in the description box. You can get from there. And also please subscribe my channel. It makes me feel happy that my students are supporting me. Okay, thank you very much. Very best of luck, my students. Very best of luck.